Okay, so this talk will be about the experience of teaching Clojure on IFSP Campinas.
Can you hear me?
So, these were the 4 cities in which I've lived in. Here in São Paulo.
It's a pleasure to be
I
here
grew up
this
in
morning,
Cabal. I have studied and worked in São Carlos and studied and worked in Campinas.
So
now I'm moving here back to São Paulo.
I am Eric, and
I have an academic industrial background. I have been a developer and professor for about 5 years each. I'm a bachelor and master in computer science, and I have experiences in both private and public sectors. Are you still hearing me?
Escuta.
Okay.
No, eu estou falando que não.
These are the languages I'm most familiar with. The last one being Clojure.
Test.
Okay. How many of you have ever heard of
So
IFSP?
let's get started again. Good morning, everyone. I'm Eric. This is Riyad.
Well, IFSP is the Federal Institute for Education, Science and Technology of São Paulo State.
Tem uma galera que não tá ouvindo.
It's a public teaching institution and it provides secondary and tertiary education. In Portuguese, ensino técnico e superior. This is the São Paulo State again. We have campuses on many cities.
So good morning, everyone. I'm
also
Eric.
here in
This
São
is
Paulo.
Riyad. We are both
It's more than 100-year-old teaching institution.
And today we're gonna talk
had
about
some other
running
names
multiple
before.
banks at once.
You might know it by the name of
So
Cefet.
first things first.
And I've been
for those
there
who don't know
since
Nubank
2013,
yet,
first in
or
São Carlos,
doesn't
then
know
in
too much
Campinas.
details about Nubank. We are
These are
fintech
some of the regular
that started
subjects
to
that I have
operate
taught there.
like 5 years ago.
Programming languages, game
And as you
development,
can
web
see on the
development,
chart,
and some others.
since then we double our
These
size.
are the extension courses that I have applied there. For the first one in São Carlos in 2013,
Just a sec,
TDD.
please.
Then in 2017, basic chess. I like chess very much. And then now on 2019, introduction to functional programming with Clojure. So what's an extension course? By the way, what's extension?
Can you hear
Extension is one of the pillars of teaching institutions in Brazil, universities and similar institutions. Extension is about things that involve the external community, things that interest the external community. Could be courses, lectures, events, shows, and many other things. These are some of the extension courses that are offered at IFSP Campinas. And why create another one? Why create a functional programming or Clojure course? Well, in Campinas we have audience for that. It's one of the biggest centers in Brazil for technology.
This one works
and software development.
for everyone?
Nowadays, functional programming is everywhere, except in some college curriculum. So, not every college teaches functional programming. And Clojure is becoming widespread. If you look for jobs in Clojure, you will find them here in Brazil, especially here in São Paulo, but also in Campinas. And Clojure fits well in an ongoing Java project. So if you already have a Java project, you can create a new model in Clojure and it will work fine. Clojure is a Lisp dialect. It's dynamically typed. It was created by Rich Hickey and released in 2007. It's more pragmatic than philosophical. It has many principles, but when you have to get stuff done, Clojure favors getting stuff done. It favors immutability, just like you would expect from a functional programming language, but it does not enforce it. It favors idiomatic constructs, but it allows everything else. You can write any code you want in Clojure, any valid code, of course. Especially Java interoperation is something that's quite usual and easy to do in Clojure. What does Clojure code look like? In case you have never seen Lisp code, remembering that Clojure is a dialect of Lisp, this is what Clojure code looks like. These are two functions, one that takes some game data and transforms it into a string, into a text, and the other one transforms it into a map to be later transformed into JSON. So you can see it's very different from usual code in Java, C#, Ruby, and other languages. Let's talk about the inception of this course. It all started in October 2018. This was me running on the treadmill of my building. And I was watching Clojure talks by Rich Hickey. And I found it to be very nice. I thought it was cool. I thought I should learn that stuff. And one of the best way to learn is to teach. So I thought, well, there will probably be a good audience here in Campinas. So let's do that. Let's make an extension course. To do that, you have to wait for the call for proposals, you submit your proposals, make the requested changes, hope that it gets approved, you apply the course, and Bob's your uncle. Bob's your uncle is like a noise in English.
Test. Now. Can you hear me also?
On October, the call for proposals was open.
So, let's go.
Then I have filled a few pages
everyone.
of information about the course that I was
I'm
proposing,
Eric, and this is
including
Riyad.
bibliography, motivation, and all that stuff.
And
it was accepted by the Campinas campus, and there was still the lack of approval. It still needed acceptance by the Vice Rector of Extension here in São Paulo, which was expected for late January. Then from December to January, I have there was the promotion of the course on the IFSP website. I have also written an email to some friends, to some former students.
Since then. And now we have more than 12 million customers.
The State University of Campinas,
2,000
and they
employees.
promoted it there.
And besides Brazil, we
and I have also made some
starting to
physical
run
A4
on
posters,
Mexico
which were
and
like
Argentina as well.
And you know, I was kind of
So
very
here are
proud
some
of that.
engineering
I thought,
numbers.
wow, this poster
We have more than 300
pretty. It took
microservices.
many hours to do.
We have more
and
than
it
100
has QR
million
code,
processed
so
messages
it will be
on
a huge
Kafka
success. People
on
will
a
see
daily
that,
basis.
and they will
And
really become interested in learning Clojure and go to
receives
the
more
course.
than 1 billion HTTP requests
in February,
every day.
I got the acceptance by the Vice Rector of Extension, and the course started on February
Let's
the
pause
12th.
again because some of you
There
are
were
not
51 students registered,
able to
inscritos. There were 22 enrolled, matriculados. They really went there, took their documents, and registered formally their interest in doing the course. After 1 month of course, we had 16 students, and 9 of them have actually finished the course. So you can see that the number decreases, and that's normal, that's expected. By asking them, I have found out that of those 16 present, after the first month, approximately 19% of them were Unicamp students. Approximately 12% were current IFSP students who got to know the course. Okay, so how did I start learning Clojure to teach it? It all started many years ago. On 2011, I have been through this tutorial called Learn You a Haskell for a Great Good. And I learned a lot from that tutorial. I haven't done it completely, but it was my first contact, my first real contact to functional programming. On 2014, I have attended this online course from Coursera, which is great. I highly recommend that you do it if you're interested in functional programming and programming paradigms. And there will be a new class starting on September the 2nd, so if you're interested, go ahead. It's now divided in 3 parts, part A, B, and C. It used to be on a single part. And on 2019, I have studied Clojure, especially using the website and the official guide, which is very good. It's very objective. It's very based on code and practice. I have used the REPL. When you hear about Clojure, you will hear a lot about the REPL. It's very powerful in Clojure, and it's a great learning tool as well. There's this website called Learn X in Y Minutes, which teaches you many languages by just showing code and comments in a very objective way. It's great to have an overview of what to expect from some new technology. So I recommend that you start learning Clojure if you want. If you want a concrete overview, a quick overview, Learn X in Y Minutes. If you want explanations and exercises and you're going to dedicate more hours for that, the official guide. And if you just want to play around and see what Clojure code, how the code runs, just go to Replit. It's a website with REPLs for many languages. If you want to set up your local environment, I recommend using Leiningen, which is a project build tool similar to Maven, but much easier to use, and Visual Studio Code with some extensions. These are the extensions that I have used. They worked pretty well for me. I tested some other ones, but I hadn't a great experience. So I recommend these 3 ones. Okay, so what was the course like?
And this is going to be the agenda for
The course
today.
load was
We are
30
talk
hours
about
divided
tech
in
stack and
18
microservices.
weeks, and the classes were
Then
on
we're
Tuesdays
going
from
to talk
7
about
p.m. to
Shark.
8:40
That's
p.m.
how
So it's a
we
time in which
scale
people who work at
building
commercial
multiple times.
time could attend.
Then we're going to
It
talk
was a
about
classroom course. It
immutable
was not an
infrastructure.
online course.
That's how we create and destroy
This is
new
the
things.
basic curriculum for the course. So things about
And
functional
last but not
programming,
least, we're
then
going to talk
Clojure
about
syntax, Clojure
building,
tools,
engineering
how to
tooling
do
and
mutability in Clojure, how to
So
structure a
tech
project,
stack,
records,
and
macros,
hear
and
about
parallelism,
two
just an
things,
overview.
tech stack. You
And then
probably
on the
already
last
heard
class, the
about
students were
Clojure.
supposed to present the
So
project that they
more
would
than
develop.
90% of our services are
It was divided in
Clojure.
3 phases,
So
this
Clojure is
course.
a functional programming
On the
language
first phase,
where
we
can
saw functional
handle
programming concepts in
immutable
JavaScript.
data structures,
And then you might
then
think,
we
well,
can
but how are
isolate
you going to
functions
teach
from
Clojure in
side effects.
JavaScript?
Clojure
With Clojure
also
script?
is
No,
a
that was
Lisp
not the
family
point.
language.
The point
That
was
means we
that
can
Clojure
use macros
is
like
a
Lisp, and then we
is
can
a hard
use
language. I
assembly
think it's a
language.
hard language for a newcomer to learn. You have to learn
Clojure
lots of
runs on
stuff if
JVM.
you're coming
That means
from
we can
a Java or
access
C#
that
or
code
Ruby
and then
background.
we can create more
If you're going to learn Clojure
abstractions
together
from
with functional
Java.
programming for the first time, it
For
will be a
database,
very hard
we
task.
use
And
Datomic.
JavaScript is much more
Datomic is a
familiar
database
for
that
many
never
programmers
changes the
than
data.
Clojure and
So
has the functional
it
constructs
keeps
that
the
you need
track of
to
all the
start
changes.
learning the paradigm.
So
So I
you
thought it
can
was
query
a
data
great
from
way to
any
make
point
things
of
easier
time
for the newcomers.
because,
Then we had
the
Clojure
data
introduction
that
and
we
then
needed,
classes
obviously
about how to
won't be
develop a
lost
project.
because,
So on
uh,
this first phase,
Datomic
we
gives
learned
a
the
track
functional
like a
programming
package.
concepts and applied them in JavaScript.
So,
On the second phase,
Datomic has
we saw Clojure,
also,
the first steps,
multiple storage
beginning with the
options
prefix
because Datomic
notation, which is
doesn't
something
do the
that is not trivial
storage itself.
to learn, but you
So
can
choose
learn it,
between DynamoDB
absolutely
or
can
a
learn it.
SQL database, or
Then some
even
other
custom
language features and the
and you
built-in
can
data
use
structures of
mostly,
Clojure, which are great.
RDS from AWS.
We also
and
saw
then
things about project development. So how to structure a project, how to use the lining and tool,
Kafka.
how to use a web framework, the most
Kafka
famous
you
one is
can
called
create
Ring,
topics
and
some
how
services
to
can
make
produce
atoms and
messages
mutability, because
to
on any real
those
project
topics.
you have to do
And
that
then
in
some
Clojure.
services can consume those data.
So how was the course applied?
Kafka also handles a
To
huge
show
amount
you,
of
I've
data,
brought
so
here
we
some
can rely
exercises
on
that
Kafka
we
to
have
do
done
all
in the
the
classes,
communication on
so
the
you can have an idea of the
And
contents of the
if
course.
something goes wrong
On the
with
first class,
message consuming,
one of the questions was
we
this
can
one,
just replay
to
those
find out
messages
which of these
and make
functions
sure
were
that
pure.
all the messages
So
is
the
always
students
delivered.
had to think about
So
if mutability is happening or not, and if side effects are
they
happening or
decided
not.
to put all these types together,
Um,
was by using the microservice architecture
Another
to
exercise on the next class
be
was to
more
write their own
specific,
version of the
our
map
partial
function.
adapters
Write a
architecture,
function that
with
receives
some
an
extra
array and a
extra
function,
links.
applies
So
the
let's
function
start
to
with
every
the
element of the
functions.
array and
Besides
returns a
of
new
course,
array.
and the adapters
This was the
itself,
kind of
we
exercise
also have the
that
controllers
tutorial
and the
Learn
logic.
Your Haskell
So we
proposes,
deep
and I
into
found
it
it to
to
be
understand
quite
exactly
effective
how
to
those
learn
work,
functional
how they work.
programming.
So the first one is the parts. Parts
Another
are the standard
exercise
component of
was
each
to write a
microservice
function that
application.
returned other
Some
functions,
examples
so
are
it
parts
generated
are the
other
Kafka and
functions.
also the Datomic.
It may
So our
sound quite
microservices rely
trivial
on
for
parts
who's
that
already
can do
used
external work
to
and
functional
also
programming.
to
But
interact
for
with
who's
our
not,
third-party
for
providers
who's
or other
seeing functional
microservices
programming for the
inside of
first
our-
time,
of infrastructure.
it might seem
So the
quite
parts are kind of
quite
computer
strange.
functions for
How am I going to write a
They are
function that
responsible
returns
for
a
handling
function and
those
receives a
electronic
function and
communication.
function? And
Some
when
of the
they
examples
get used to it,
besides of
they find it
Datomic,
quite
we use
natural.
also
But
HTTP
you have to
as a
really
port.
put
The
that
port
into
should,
very
have
small
a lot of,
doses so they
logic
can
inside it.
get
Just
used
we
to it
can
and learn
make
more
sure
complex
that
stuff.
We can reuse this code among our,
Another exercise, this time about recursion, is to
So
find
inside
out
Nubank
what
we
is
have
the
some
function. What does this
common
function
libraries,
do?
and most part of our
I
parts
bet any
are
student
maintained in a
who
repository called
knows
common
something
chapter,
about
common
JavaScript
common HTTP
or
server, common
algorithms
HTTP
can
and
be
things
able
like that.
to and knows a little
So
about recursion,
The
of
next
course,
part is the adapters.
will be able to
Adapters
find
are
out
the man in
what
the
does
middle,
this do.
in every communication between services
But what about
or
this one?
external providers or third parties.
This syntax is another syntax, but it has the same effect as this one. It's the same function, it does the same thing, but it's much more implicit.
So
So, for example, our third party can use something like XML for
One
computation.
of the first exercises that I have proposed when they started learning Clojure itself was to write these expressions in Clojure using prefix notation. It's the kind of exercise that we start to do when we first learn how to program. Write this mathematical expression using a programming language. But this time, it should be in prefix notation. So, minus TF32 inside parentheses. That's what the Clojure code would look like. This was a more difficult exercise. Write a tail recursive factorial function in Clojure. Most of us have learned how to program recursively using this exercise of factorial. When you're learning a new paradigm, it's pretty much like learning how to program for the first time. So this kind of exercise is welcome. Then on one class, we have made a dojo, a coding dojo, using Ring and Composer to make a small web application. And I think that was very good for them because it's more like what they would do on a daily job. They would have to solve problems, and problems involve not only the language or the concepts, but also the structuring of a project, learning how to use libraries and tools. So it worked pretty well. The project was supposed to be done in groups of 2 students preferably. They were supposed to choose one theme among some options, and they should develop a simple application and present it in 10 to 15 minutes. These were the available themes for them to choose, and these were the students, some of the presentations that they made. I think that also has given them a chance to see how Clojure would look like in practice, in a real project. Even being a very small project, they had to go for it, and it was challenging, and they have learned a lot. I have conducted many surveys to assess the way that the course was going on, and I will show you some of the results I got.
So that's why you can see a fake image on top of the.
On the third week of class, I have asked them via Google form what did they find, how did they find the level of difficulty of the course. It surprised me that 50% of them thought it was too easy. Some of them said it was too hard, and a big number said it was okay. 3 weeks later, I have asked the same question, and the okay number grew up a little, the too easy dropped a little, and the too hard dropped a little too. 3 weeks later, that number went to 100%, so I think the level of difficulty got finally right. For people who wanted more challenging exercises, I have provided some of them after the regular exercises, so they got busy. Maybe they got too busy and they thought, oh, I'm not going to ask for more difficult stuff because I might regret that. I asked also on the third week whether using JavaScript was helping them to understand the concepts, or if it wouldn't make any difference. 100% of them said that yes, JavaScript was making things easier. And I have felt that too during the classes. I felt that the students found JavaScript familiar enough to learn the concepts. And the concepts were hard enough. There shouldn't be many obstacles for them to learn functional programming before diving into Clojure. I also asked them this question: how do they prefer studying Clojure? Do you prefer learning first the theory, all the theory available, then the practice? Not all the theory, but much theory, then move to the practice? Or do you want to learn only what's the bare minimum to start doing exercises, then after doing the exercises you return and study some more theory? It was kind of divided. So I believe that both ways would work for that classroom. I also asked about the coding dojo, what they think of it. 80% liked the idea, thought that it worked well. 10% thought that the idea was good, but it needed some adjustments, and 10% of them said they had another suggestion for what to do in the class. Unfortunately, I don't remember what the suggestion was. When the course was about to end, I asked them what was the course like in relation to their expectation before it started, and I was quite happy because 37% said it was according to the expectation, and 62 said it was above. So I got quite happy because of that. There were only 8 answers, so I don't know the other people what they found. What did they find about the course? Maybe the ones who thought it was below their expectation had already dropped, so I didn't get that number. And one of the lessons that I've learned that I didn't write here is that when you're collecting data, it's quite an obvious statement, but I learned that in practice, was when you are collecting data, the data is almost always not precise. And you have to work with the data that you have. And that's just a fact of life. It's quite obvious, but I really felt that happening here. On the last day of class, of the course, I have conducted an informal survey. I asked the students what did they like most and what did they dislike most about Clojure. And here are some of the results. Almost everybody liked the REPL. Some people liked the standard data structures, list vector set map. They liked the tools, especially lining it. The ring middlewares, they work pretty much like Express.js on Node.js, and they liked it, the way that it worked. And some people like the idea to use vectors to store pairs. In Clojure, you don't write classes to represent your concepts. In Clojure, there's this culture to really use simple data structures to represent information. So the information is stored in integers, strings, vectors, lists, maps, and that's pretty much all you got. There are some other things, records and stuff, but if you want to store a pair of data, why don't you just put them in a vector, whose first element is the first element and the second element is the second element? It's kind of obvious, but people who come from Java, and that's my case too, are not used to do that. In JavaScript, it's more common, but some students like that culture. I liked it too.
Another thing that
students found it difficult to find the parentheses to close. That's really a problem when you are starting to learn Clojure and even later. The error messages in Clojure, they didn't like it. Tail recursion, some students found it difficult. And the thing of chaining functions, some students found it hard too. You know, when you're calling f of g, of h, of I, of j, of something. And that's why Clojure provides an operator which is called the threading operator, which looks like an arrow, and helps make your code look cleaner. I haven't taught that in the course, but I have told them after they said this to me, and I saw that they liked it. They thought, oh, it's good that Clojure provides something that will solve my problem. And I think that's part of the Clojure experience. Clojure always provides many specific tools for specific tasks, and it's interesting when you find the specific tool for your specific problem. It's a rewarding experience. One thing that I've noticed is about this discussion of simple and easy. If you haven't seen this talk yet, I highly recommend it. I think it was one of the students who recommended it to me by Rich Hickey. It's called Simple Made Easy. And he makes a clear distinction between what's simple and what's easy. And this applies for every programming language. He says that a simple thing is kind of an objective concept, and it means that something is the way that it is. It doesn't have many dependencies on other stuff, and it's not entangled. It's not like this, it's like this. It's clearly, the parts are clearly distinguishable. And easy means something else. Easy means something that is near, it's at hand, it's close to you. It's quick for you to do an easy thing. It doesn't cost you much energy. And that's a subjective thing. That's highly relative. And Rich Hickey says that when you are developing a real system, It doesn't phrase it like that, but that's the idea. You should prefer simple designs and implementations, even if they are not simple. You might need to learn lots of stuff to do simple stuff. It might be hard to do simple stuff, but simple stuff has more value than complex stuff. But what I found out is that when you are teaching an introductory course, sometimes you should prefer the easiest stuff, not necessarily the simplest. This syntax, the top one, is the traditional syntax of JavaScript functions, and it's more complex than this syntax. This syntax is simpler. But for who comes from a Java background, a C# background, this syntax might be much more familiar. And familiarity and easiness have everything to do. This syntax might seem quite obscure for who comes from an imperative background. So, when you are teaching an introductory course, it's preferable to have a more complex syntax if it's easier for the students, especially because the course was not about JavaScript. The course was about Clojure. JavaScript was just a learning tool. So, when you are developing a real system, I think that you should prefer this syntax, which is simpler. But when you are teaching, when the understanding of a person is really, really important, and that person prefers something more complex because it's easier, you should prefer that. Okay, so let's talk about my Clojure, my impressions of the Clojure language.
In a repository that our developers from all squads can read and understand how we provision infrastructure.
About parentheses. Parentheses are a controversial theme in all Lisp languages. Every Lisp language looks very different because of the parentheses. I found them to be not that hard. It's hard in the beginning, but you get used to them somewhat quickly, especially because you just have to. But I do recommend that you use a rainbow parenthesis plugin, which makes them look like this, so you know that this one is getting close here, and this one is getting close here. It looks quite trivial in this example, but on real code, it really can get quite messy. It's better yet if you are able to use the Quickie tool. It's a tool that runs your automated tests every time you save a file. So if you forget a parenthesis, an error will pop out. You just press Ctrl-Z and it gets back to the other state, and you will see that it was the parenthesis fault. The pros of Clojure, some pros of Clojure, it has a great documentation, both online and via REPL. It has great built-in data structures, list, set, vector map. It's fun to work with them, and they are efficient. The automated testing framework in Clojure is actually built in the language, and it works pretty well. It's pretty simple. I will show you an example. Clojure is fun to learn and to use. It's a challenging and rewarding experience. And sometimes you have that finally free feeling. If you come from, especially from Java and C# backgrounds, you are used to creating classes for everything, even for small things. And this sometimes makes your code unnecessarily complex. And in Clojure, you can just write data structures. You can just pass values around. You can just pass maps around. You can convert them to JSON and back from JSON, and there's no problem. And it just works. You just do it, and you say, well, it's simple. That's what Rich Hickey says this a lot. And you also have to be very responsible with your code, because if you don't, it will easily become a mess. So you have to use that carefully. Some cons of Clojure, in my opinion, it's a complex language. It's not a simple language. There's a lot to learn to start doing something minimally productive. There are many ways to do everything. This has some pros and cons by itself. And it has some awful error messages. And that really makes it difficult for newcomers. This is an example of an automated test. This is the test that's generated automatically by Leiningen when you create a project. It's just simple as that. Def test, testing, and a string is an assertion. and then you pass an expression. If it evaluates to a truthy value, it passes. If it doesn't, it fails. And it even shows you in the console this expression here in source code form. And that's because this is a macro. Clojure has the power of macros. It's quite another world to study. There's even a different article in Learn X in Y Minutes only for Clojure macros, but they're fun to use. They just solve the problem and they're fun. This is another macro. This is another test. Instead of is, it's written are here, which is kind of is for many cases. So by using this expression, you are testing that this equals this equals this, and this equals this. So you can write a complex test in simple terms. It's really cool. In Clojure, I said that there are many ways to do the same thing. So suppose you have this map and you want to transform into this other map. So you want to increment that 2 to become a 3. Suppose you have this map in a variable. There are at least these 4 ways to do that. And for who never saw Clojure code, it might seem quite strange, but when you study it, you see that it makes complete sense. I don't recommend you to simply go for this simplest solution, the 4th one. I recommend that you first try doing it the most difficult way, the most manual way, which is the first one. Then you try to refactor that to become a little more concise by using built-in functions in Clojure, in this case a soak. And then you try to refactor it to become a little cleaner, because that will give you a good understanding of what's going on. The error messages. Suppose that you just forget a parenthesis. It happens a lot. You will get punished for that. You get severely punished for that. Here says that there are 153 more stack trace elements here than those that are shown to you. And it happens all the time. At some point you get used to it and say, okay, I probably forgot a parenthesis here. But other errors produce sometimes this same stack trace, and it doesn't help you at all. Clojure has its pranks, pegadinhas in Portuguese. I'll list some of the ones that I found. The function conj that you use a lot, it inserts at the beginning of lists, but at the end for vectors. It inserts at the position in which it's the most efficient way to insert into that data structure, but that might be confusing. The contains function checks if an element is contained in a set, but if you apply it for a vector, it will check for the index. There's this function called intersection from the Clojure set namespace, but it only works for sets. If you try to use them for vectors, you'll get an error, right? No, it's wrong. If you call this function for a vector, for 2 vectors, I mean, you'll get a wrong result. So be careful. Clojure will not validate many things for you. You have to be quite careful. Clojure has this philosophy of not validating input sometimes. I'm not sure why is that the case. They probably have good reasons for that, but that's just a prank that you should be careful with. The keyword, I mean not the keyword, the command deff creates variables, right? You learned that on the first page of the Clojure tutorial. The second command, defin, creates a function. And we know that in functional programming, we favor immutability. So we expect the function f to be called and return 10. And then if we change the value of the variable a here, we expect that the function still gives 11 as a result, because it should still look to the old version of the variable a, right? Some other languages are like that. And that's what you would expect from functional programming, but that's not the case of Clojure. F now looks at the new variable of a. It's not just a shadowing phenomenon. Def creates a var, and vars are mutable. Vars are mutable. One of the first things you learn when you start learning Clojure actually creates mutable stuff, which you shouldn't be using at all. So you should be really careful with that. There are reasons for that. There's this, I think, macro called with redefs, which allows you to replace vars with new values only in this context. So if you do this, this call of f will return 31, but future calls of f will return 21 again. So there are advantages for that thing to work like that, but you should be really careful. So use def very carefully, prefer let whenever possible, which creates a local binding. And if you want to write a function that shouldn't be used anywhere else outside the namespace, use defin minus. This is a real identifier in Clojure. It's really nice to be able to use some characters, some different characters. Some people say that Clojure has no syntax. From my experience, pretty much every symbol that you can see in your keyboard has a special meaning in Clojure. These are some of them. So I'm not sure if it doesn't has syntax at all. I think it does, but here's the arrow, the threading operator that I have said. There are two versions of it and some other ones. Clojure's standard library is huge. So let's talk about some references. I highly recommend these talks from Rich Hickey. Even if you are not writing Clojure code, it has good ideas for software development in general. If you are going to program in Clojure, I recommend these three libraries. Slingshot is an exception handler, exception handling library, which makes it a bit easier. Pretty is a library which makes that horrible stack trace much more readable. It works most of the time and it helps you to debug your programs. And then Quickie, which I have already said before, that automatically runs your automated tests when you save files. So it gives you a much better TDD cycle if you're doing TDD. The command line test takes many seconds to boot. So if you're doing line test all the time, you will get bored. But if you use Quickie, that problem is solved. If you read Portuguese, this is the link for the course material. You can take a look at it. And so let's finish with our conclusions. What I have learned, I might be wrong. If I am, please correct me. But from what I've learned, I've came to the conclusion that functional programming is basically about calculating the next state of the system and then switching to it. So you mutate data only on phase 2. It's pretty simple. It's a little hard to grasp when you are actually coding, but basically that's what you should do. You should leave the mutability only for the last phase in which you just switch pointers. Like you have a big tree here representing the state of the system. Then you calculate the next node, the next node, the next node. This node references the old one because of memory. It can use the memory that was already used because the data structures are immutable. So it does many optimizations. But you had this tree here, you calculate the next tree here. The system is still looking at the old tree, and then at some point in time, you just look at the new tree and the state of the system has changed. You don't make changes in steps. You just calculate the next version of the system, the next state, and switch everything to the new state. Yes, you can bring novel knowledge to your workplace, and you should do that. It's great. It's a great experience. You can make hard stuff easy for other people. Hard stuff is hard stuff. You should learn it. You can learn it first and then take it to other people and make it the most easy, as easy as possible. And that will be great for you too. Clojure is not very welcoming. It has nasty error messages. It's not appropriate for new programmers, in my opinion. There are other Lisps that might be, like Logo or Racket. Clojure is not that hard, nor that easy, and in my opinion, it's not simple. It's a great source of ideas and tools for software development. It's a production-ready ecosystem with a big community, and it's pragmatic. It lets you do anything you want. And that leads me to the final lesson that I've learned, is that things evolve according to people's needs, not always to the original principles. From what I've heard in the talks of Rich Hickey, some of the things that he said that were good, I had a different impression in Clojure. But what I learned is that that's just life. You can't always do what you thought was the best in the start. Sometimes you have to change path, and that's okay. That's how things evolve. And I'm leaving IFSP, and I'm joining Lambda 3 next week. It's a software company here in São Paulo. And that's it. If you have any questions, I think there are a couple of minutes now, or you can send me an email or a Twitter. Thank you very much.